Well, folks, it appears that part 7 on this series has got a few people confused. To take, for instance, Wayback Tech here, he says, I've learned that when these old schematics show a ground, it might not really be a ground. Mind-blowing. Well, of course it's mind-blowing if you think that way. If the schematic shows a ground, it's a ground, okay? It's nothing else but a ground. And he's got, for instance, he says, schematic shows a ground from pin 4 of the tube, which is the cathode, okay? Which is really not going to pin 4. Of course it is. I'm going to show it to you right here. Are you ready? Here you go. Now, don't think too much into this stuff. If you think too much, that's when it gets confusing. Let's take a look right here. Now, here's pin 4. It goes up to the cathode. Now, pin 1 and 5 are separate. It's the cathode that's grounded. Now, over here on this capacitor, it needed a ground. So what they did was they took the ground and they hooked it to this ground over here. It needed a ground, so they just connected it to there, okay? That's all they did. They shared the ground between those two things, pin 4 and the capacitor. Let's see if we can find another one. Here's another one over here. For instance, now here's another capacitor that is needing a ground. It could have taken that ground and ran it over here and connected it also to that same one right there. Okay, it could have. It didn't. I mean, ground's ground, okay? Keep in mind, we're still, let me get some more focus in here. We're not even talking about pin 1 and pin 5, which is your heater, separate from the cathode, okay? Or they could have gone down here and connected it to the grounding tab for this resistor and this capacitor. They could have done that. Or let's continue this even further. They could have gone down here and soldered it to this ground right here. You know, they could have taken it anywhere, or they could have just taken it and connected it to the chassis anywhere. All right, just put a grounding, drill a hole, put a grounding tab and connected it there. Ground is ground is ground. All right. Sky Carl says, so the A coil, is it like a secondary coil on the primary side? You know, we look at schematics later than these. This is a 1931 chassis, 1931 schematic. We're used to looking at schematics, you know, 36, 37, 38, 39. And during the time, from the time this radio was made to later on in years, they probably decided to move, you know, this little coil here that provides, actually it's not a coil, it's a winding, you know, and this little winding in the primary, they probably decided to move it over to the secondary. I don't know, it doesn't matter, it's AC. It would be AC here, and if you move it over to the secondary and you do not rectify it, it's AC again. I mean, what's the difference whether you get it here or you pick it up over here later? You know, we're so used to seeing it in the secondary, we just don't even think about ever having been in the primary. I think I've seen it in the primary before. Someone also asked about the rectifier tube filament. Well, this is a filament right here. See, these up here are heaters. The heater heats the cathode, but down here you have no cathode, so it's a filament. But you'll notice right here that the 80 rectifier tube has its own dedicated winding right here. An 80 tube filament takes 5 volts. All right, pin 1 and 4. And incidentally, all the rest of the tubes in this chassis only take 2.5 volts. They don't take 6.3. They take 2.5 volts. I mean, we're barely talking any voltage here. Just enough to get the old tubes going. But the old rectifier takes 5, and that's pretty standard, you know. You'll see a separate winding in the secondary to feed the rectifier filament, okay? Let's take a look at my Hammerlin HQ129 filament setup. These filaments here are all in parallel, okay? The heaters here are also all in parallel. That's, you know, from here on the A, remember I told you along the right hand side of that chassis one was all connected together, fives were all connected together. That put them in parallel, and this is also in parallel. Now here's what happens, they're not going, when they write a schematic, they can't draw a line from every single contact point. Well, they don't want to. It's easier to just put a ground there and a ground everywhere else, and then you automatically know that those 2 points are connected together. They could just run a wire to here, to here, to here, to here, from the various points in the power transformer. But after a while, you'd have such a busy schematic. You've had additional lines going everywhere. So rather than do all that, they just put a little grounding symbol here, and everywhere else we want to show it being connected, we just put another grounding symbol, another grounding symbol, all the same point, okay? And if you look right here on this filament string, if I were to take my little old whiteout pen, we'll just go ahead and do it. We'll just go ahead and white out. We'll white out that ground right there. Then we'll come over here in the end of this thing and we'll white out the ground right here. Those 2 points would actually be the same, okay? But we'll go ahead and white them out, and now we'll, instead of just showing a grounding symbol, we'll just go ahead and take a pencil and bring it on around like so over to there. So now we have a complete circuit, you see. All grounding points are connected the same if they're connected to the chassis. Make it a little bit darker. Now, I understand the problem you all are having with this ground business. It took me quite a while to figure it out too. Now what we have is a transformer winding that goes down through, goes up, 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 all the way down like that, up through, up through, up through, up through the lamps and everything, and then when it goes up through and it comes down, it connects to the return line. Each of these comes around, connects to the return line. The return line being all the way back to here like this, okay? So you have a complete circuit, which is exactly the way it is with this filament right here on the 80 tube. Down through the coil, through the filament, up and back. A circle. A circle with a bunch of stuff in between, that's all. I hope that helps. Let's look at one more scenario here on this heater voltage business. Let's say this little 2.5 volt winding, the A winding, let's say it crapped out. It burned out. Everything else in the transformer was good except for that. It crapped out. What do? You just throw away the transformer and buy another one? Yeah, you could do that. Or you could find a replacement, from another radio, from a junk radio. Or for that matter, you could just go to one of the sellers on the internet and pick yourself up a little filament transformer, cut down the voltage with a resistor to 2.5 volts, and then feed it to the heaters. Okay, just as if it would take the place of this little winding right here. So you would essentially, what would you have? Well, you'd have another little tiny gold-colored, transformer. As long as the transformer could handle the current draw of the tubes, the filaments, you're good to go. One of our other good subscribers, he made a comment. He wanted to know if I put that smiley face on that tuning meter. I hadn't even noticed it until he mentioned it. That's pretty funny. Okay, let's go ahead and end this part right here, part 8. I've got part 9 already completed. I'll be uploading it later, but I wanted to just kind of do my best to answer these questions. I hope things are cleared up. I really don't want to explain how everything works. That's not the what they call the purview of this series. All I'm trying to do is show you how to follow wires, okay?